13 beautiful pairs. So I'm gonna first explain the solution of how to solve the problem, and then I'm gonna explain the code. Definitely this is gonna be a really hard problem. Let's first try to understand the problem. So we are giving a two zero indexed integer array nums1 and nums2. As we can see, the length of nums1 equal to the length of the nums2 because this is just according to the description. Yeah. And we have a formula. So a pair of indices I and j is called beautiful if nums1i minus nums1j plus nums2i minus nums2j is the smallest among all possible indices pairs where I less than j. So how can we understand this kind of a formula? Yeah, so let's just try to use some examples. Definitely we're gonna return the beautiful pair. So we're gonna return this kind of a beautiful pair, and the beautiful pair gonna be the smallest pairs. Yeah, it's gonna be the smallest among all possible pairs. Yeah, so if there is a time, so we're gonna check this kind of a formula. So this is how can we calculate the absolute value, and this is for checking the time. Yeah, so this is what called lexicographically smaller. So for I1, J1, yeah, if it is lexicographically smaller than I2, J2, this means I1 less than I2, or if they are equal, so we're gonna compare the next y coordinates. So J1 should be less than J2. Yeah, but first of all, let's try to understand the problem. Let's just use the example. So from here, we're going to use this index 0 and 3. So this is going to be 0 and 3. Here going to be another 0 and 3. And we're going to check the absolute value of 1 minus 2 plus absolute value of 2 minus 2. Yeah, so it's going to be 0. And if this is going to be the smallest, it is 1. Yeah, so if this is going to be the smallest value, and the I also appears first, or J also appears first, so we're gonna choose this pair 0 and 3. So this is gonna be the final result. Yeah. So I mean, if there are some ties, so for example, there's another one, maybe the same distance. Yeah, it's just an example, maybe 1 and 2, but definitely we're gonna return 0 and 3 because 0 appears first. Yeah. So this is the meaning of the problem. But now, as we can see that this is for the coordinate x. This means for 1, this means a coordinate x, maybe it is xy. This is another coordinate x. We can understand the nums1 in the x coordinates and nums2 in the y coordinates. So this means x1 minus x2 absolute value plus the absolute value of another one. So it's going to be this 2 minus this 2. So yeah, so it's going to be another dot. So for the other dots, we're going to use let me just use y1 minus y2. Yeah, so this is going to be the formula. So x1 is from here, so this is x1, and x2 is from this number 2. Yeah, and y1 is from this number 2, and y2 is from this number 2. So as we can see from that, this is kind of like Manhattan distance. So we want to calculate the smallest Manhattan distance in a plane. So this is the x coordinates. So x1, y1 is going to be a pair, and x2, y2 is going to be a pair. So the pair means just coordinates. x1, y1 is a coordinates in a plane, and x2, y2 is another coordinate, another dots in a plane. We just want to calculate, and in the plane there will be many dots. We don't know how many, but definitely we want to calculate the shortest distance among all those dots. So maybe this one gonna be the shortest, or maybe this one gonna be the shortest, but we don't know it yet. Yeah, definitely this is gonna be a really hard problem. Yeah, this is a computational geometry problem. We want to calculate the shortest distance between any two dots in a coordinates plane, in a coordinate system, or in a plane. Yeah. So if we understand the problem now, we want to find a solution to solve the problem. Yeah. Now let me just draw some examples. So this is some dots in the plane, and definitely we want to calculate the shortest distance. Yeah. So if there is a duplicate dots, so if two dots, so for example this is A, another dot is also A, another dot is B. Yeah. So if it is the duplicate dots, so it means the distance is going to be 0, and definitely, and we want to get this one 0 as the shortest. So if it appears first and it's also is a duplicate, and then we're going to return the answer immediately. So maybe this is the first dot is I, the second dot is Z, and we're going to just return this I and Z. Yeah. But how can we check the duplicate? We can use a hash table, and we're going to put all those X and Y coordinates inside of the dictionary as the k value. Yeah. We can also, and then we're going to put the value as a list, and we're going to put the index I and Z. So for example, the first one is maybe 0, the second one maybe 1. We want to put it inside. Yeah. So if the length of this is the k-value pairs, so if the length of the value of the list is more than 1, definitely there's a duplicate, and we're going to return the first appeared duplicate pairs. So it's going to be 0, 1. This is easy. Yeah. But if there are no duplicate dots, I mean all the dots are unique, so this is going to be difficult. Yeah. So this is exactly like this. So all the dots in the plane are unique. So we want to find the smallest distance. If we use brute force, definitely it's going to be n squared, because we want to enumerate all the possible dots and calculate the distance. Yeah, I'm not sure if n squared can solve it even. Yeah, it's going to be n squared. Basically, we need to enumerate all the possible dots, but this is going to be a really big value, 10 to the power 5. This means we cannot use brute force to solve the problem. Yeah, we have to find some clever way to solve it. So the idea is that we're gonna use the divide and conquer to solve the problem. First of all, we're gonna sort all those dots according to the x coordinates. Yeah. So if we sort the dots according to the x coordinates, and then we're gonna find the midpoint. So this means we're gonna divide the whole problem into two parts, and then we're gonna solve the subproblem from the left side, and we're gonna solve the subproblem from the right side. Currently, we don't know how to calculate how to solve the subproblem from the left side. But what if we know how to solve it from the left side? Maybe from the left side we find the sorted distance, maybe those two dots. Yeah. So currently, then this distance is 1. Maybe this is a possible answer. Yeah. Maybe let me just use a bigger value. Maybe this is 10. This is going to be the minimum distance from the left side. And also, I know the position of those two dots because basically it is the index. Yeah. So what if I can calculate the sorted distance from the right as well? So the distance, maybe this is 11. Yeah. But which one gonna be the shortest? So the 10 gonna be the shortest. So currently we're gonna record the distance of 10 and the position of I and Z from the left side as our possible result. Yeah. But this is not yet the final result. We have to merge them together because we divided it from the midpoint. Maybe this is the midpoint. Yeah, so this is the midpoint. We have to check all the possible values from the left side and from the right side, compare with this midpoint. And the idea is also the same. We're gonna just check the distance from all those points in our range. So currently the range is all those areas. Yeah. So this one, this dot to this dot, maybe this distance is 5, and this one gonna be the unsorted distance. Now this 5 gonna be the final answer. Yeah. So now the problem comes: how can we solve the left part, and how can we solve the right part? It's the same idea. We just divide it into two parts. So maybe this is the left part, and maybe this is the right part. So the idea is going to be the same. Still, we're going to divide it into two parts, and this is the midpoint, and this is from the left part, and this is from the right part. Yeah. So this is just a subproblem from this one. So from this left one, I just divided into two parts and try to solve it. Yeah. So it's the same idea. I calculate the distance, sorted distance from the left side, and the sorted distance from the right side, and then I check all those dots compared with the midpoint. This one. Yeah. If this one is the shortest, I'm gonna record the shortest. Yeah. So the final solution may be the final one. We only have let's just use an easy example. We only have 3 dots. It's going to be like this. Yeah. First of all, we're going to divide it into 2 parts. So according to the divided conquer, according to the midpoint chosen, we're going to use L plus R divided by 2 to choose the midpoint. So this is going to be the midpoint. Yeah. Now we're going to divide it into 2 parts. From the left side, there's only 1 dot. So if there's only 1 dot, that is impossible because 1 dot cannot have a distance. Yeah. And also for the right side, there are 2 dots. So if there are 2 dots, we have a distance. So this is going to be, maybe we're going to use 10 as the distance. Yeah. So this is from the right side, and this is from the left side. Now we have to check this dot with all the possible dots in the range. So this one and this one. Maybe this one to here, it's going to be 5. Now we're going to update the final distance to 5 because 5 is the possible result. But how can we calculate from the right side? It's the same idea. So if there are 2 dots from the right side, let's put it here. So we're going to still use the divide and conquer. From here, we're going to divide it into 2 parts. This is 1 dot. This is another dot. So from here, this dot is going to be the left side. From the left side, there's only 1 dot. So there's no distance. And from the right side, there's also 1 dot. There's no distance. So if there's no distance, we're going to set it as infinity. And then we're going to compare with this dot and this dot. So the distance maybe gonna be 10. So this means we calculate the right side, it is 10. The left side, there's the infinity. But we're going to merge it, compare this midpoints with this one and this one. It's going to be 5. And the final answer is going to be 5. Yeah. So this is the basic idea of how to understand the problem and why we can use the divide and conquer to solve the problem. Basically, this is going to be really hard to think about it, and I did a lot of research and I checked a lot of materials why we can use this kind of method to solve it, because basically this divide and conquer is n log n time. Yeah, and our n is 10 to the power of 5. This is why we have to use the divide and conquer to solve the problem. And there can be some videos about this is most of the important part about this kind of a problem. Yeah. Now let me explain the code about it. So there's a lot of coding, but it is not so difficult to understand if you understand the basic idea of why we're going to use divide and conquer. Why we can use divide and conquer to solve the problem. Yeah. Now let me explain it one by one. So this is just for calculating the Manhattan distance. So for calculating the Manhattan distance, it's going to be absolute value, just this kind of a formula. We're going to turn this kind of formula to x1 minus x2 with y1 minus y2. So this is just 1 point. This is just another point. We want to calculate the Manhattan distance of 2 points. It's going to be easy. It's just a formula. Yeah. But for this DFS function, it is the divide and conquer part, and this is the main part of the problem. But I will explain the easiest part earlier. So if there are 2 dots to overlap, so if there is an overlap dots, I mean there's a duplicate dots, we can return the answer immediately. So we're going to use our hash table to prepare for that. So we're going to enumerate the index. So index is going to be the position, and the x and y coordinates inside the zip nums1 and nums2, and we want to put all the dots inside a dictionary, and the values are going to be the index. So from here we can check the duplicates. So if the length of the x and dx and y more than 1, it means there's a duplicate. Because we checked according to the sequence of the array, so this means if we find a duplicate, we can return it immediately. So this I gonna be the first index, and this dxy with 1, this gonna be on the second index. So normally from 0 it is the first, and 1 it is gonna be the second index. Because if it is a 2, we are not sure if there are 3 duplicates. Because definitely if it is more than 1, there are at least 2 duplicates. So we're gonna find the first one and the second one, we're gonna return it immediately. Otherwise, if there's no duplicate, we want to put all those coordinates inside a points array. So this one, we're gonna use this points array to solve the problem. If there are no duplicates, we're gonna use the divide and conquer. So first of all, we want to put all the coordinates x and y and the position index inside the points. Yeah, and then we're gonna sort it according to the x coordinates. So points.sort, we're gonna sort it according to this x coordinates, and we want to use a DFS function to solve the problem. Yeah. So we sort it first, and then we're gonna use the DFS from 0 to r minus 1. So this is the length of the points minus 1. Finally, we get the distance, and we get the positions of index 1 and index 2, and finally we just need to return the index 1 and index 2. Now let's go to the DFS part. And I think except that, all others should be easy to understand. And for the DFS part, I've already explained a lot of I've already made a lot of drawing to explain why we can use it to solve it. Yeah. So for the DFS part, we're gonna check the else conditions. So if this L more than or equal to R, this means there's only one dot. So for example, if we calculate from the right side, if there's only one dot, what we're gonna do? We're gonna return a infinity. This means the distance is infinity. It means it is not possible. So we're gonna return a random x and y coordinates minus 1 and minus 1. This is okay, because definitely this is just a random dots. But we're gonna use this infinity. Yeah. Now, if it is not, if there are many dots, so we're gonna check the midpoints. Maybe this one is the midpoints. Yeah, we're gonna find the midpoints. So this M actually it is the midpoints, because there will be a lot of dots in a 2D plane, and we want to find the midpoints, and we want to divide it into 2 parts, and this x is just the midpoints. So it's going to be the points M with the 0, midpoints of x coordinates. We just choose x coordinates. Yeah. Now we find the x coordinates, and we want to divide it into 2 parts. So this is the left part, and this is the right part. So from the left part, we're going to calculate the distance from the left, and the I and j position, I and j indices positions from the left side. So we're going to use the DFS L to M, and this is just the divided part. And similarly for the right part, the distance from the right and the position from the right, R and J. Yeah, R right side of the index and the right side of the index J, and we calculate it. Now we want to check the shortest distance. So currently this one is just for calculating. Maybe we've already calculated the distance from here, and this one from the right side. But we want to compare if this one is smaller or this one is smaller. So this is for comparing. So if the left side is bigger, or if they are equal, but this left side of the I index is bigger than the right, or if they are still equal, the J index is more than the right side of the J index, definitely means we want to keep the value of the left side. It means the distance from the left side with the positions going to be equal to the distance from the right side. We just need to check the smallest value, because this one going to be our final result. So we just need to record the final smallest value currently. Yeah. So currently we finished the left part and right part. We just need to compare 2 distances. If we this is a possible result, but we need to also compare the midpoints. So this is the midpoints. You need to compare all those points inside our range. So our range is L to R. Yeah. So from the L to R, so from all those points from L to R, we want to check the distance. If this distance minus the x, because we used the x coordinates, if this distance is smaller than this dl, so the dl is our shortest distance. Yeah. If this distance is smaller, we want to put it all inside a candidate. Because this is just x coordinates, we don't know the y coordinates yet. But we can first put it inside a candidate, because some of the dots definitely can be a possible result, but we don't know it yet. So we put it all those dots inside a candidate, and we want to sort it according to the y coordinates. Because if the y coordinates is bigger, so for example, the current distance is 5, yeah, but the y coordinates, the distance from the y coordinates is more than 5. Definitely we don't need it. So this is why we're gonna sort it and we're gonna break it immediately. So here, after sorting, we're gonna check that. So if the distance is more than our smallest distance, dl, so we can break it immediately. Otherwise, we just use the enumeration to check the candidates. So inside of the candidates array, we're gonna use I and j, enumerate the two positions, and we want to sort it the two positions because the index I will always goes first, and then index j. And then we're gonna use the Manhattan distance function to check the distance. If the distance is smaller, or if it is equal but the index is smaller, or if the index I is smaller, we're gonna check index j. If the index j is smaller than the previous index j, so we're gonna record the smallest result. So the dl, li, and lj gonna be the distance with index I and index j. And finally, we're gonna return the smallest distance and with the positions of I and j. Yeah. There's a lot of information, but basically we need to understand how can we divide it like into two parts, and how can we calculate each of the left and right side, and how can we enumerate all the dots from the left side and enumerate all the dots from the right side together to compare with the midpoints. We can also just delete this line, yeah, because this is just a break function. We want to let it stop earlier. Even we don't sort it, it is still okay. Yeah, because basically this is the n log n time. Yeah, now let me submit it to check it works. As you can see, it works and it's already pretty fast. But if we were to improve the speed, we want to sort the candidates array according to the y coordinates, and if the distance is already bigger, so we're gonna break it immediately. And we can still try this way. Yeah, but anyway, it's okay. Yeah. So there's a lot of coding, but I think the idea is difficult to understand, and the coding part is not so difficult to understand. Yeah, I think this is for today's problem. And thank you for watching. See you next time.